Synopsis of main chapters. AI Modeling and Process. Pradeep K. Suri. Author and researcher. Synopsis of Chapter 1, Input Dataset. This chapter focuses on the essential information regarding training datasets and their crucial role in machine learning and artificial intelligence. Key takeaways. A training dataset is a collection of data used to train a machine learning model. It consists of input data, features, and the corresponding target labels or outcomes. The purpose of a training dataset is to enable a machine learning model to learn patterns, relationships, and associations between the input data and target labels. This allows the model to make predictions or classifications on new, unseen data. Creating a training dataset often involves data collection, cleaning, and pre-processing to ensure it's suitable for training the model. Different types of learning include supervised, where the dataset has labeled data, and unsupervised, where the model must discover patterns without explicit labels. Splitting the training dataset into subsets like training and validation sets helps assess the model's performance and generalization ability. The size and quality of the training dataset significantly impact the model's performance. Larger and more diverse datasets generally lead to better results, while high-quality data minimizes biases and errors. Overfitting, where the model performs well on training data but poorly on new data, can occur with small or noisy datasets. It's crucial to ensure the training dataset doesn't introduce bias or fairness issues that can lead to discriminatory or unfair AI systems. Training datasets may need regular updates to maintain the model's relevance and accuracy as the underlying data distribution changes over time. Overall, this chapter establishes the foundational understanding of training datasets and their critical role in building and maintaining effective machine learning models. Synopsis of Chapter 2, Test Dataset. This chapter dives into the crucial role of test datasets in evaluating the performance of machine learning models. Key takeaways. A test dataset is a separate dataset used to evaluate a trained model's performance on unseen data. It consists of input data and corresponding target labels, ground truth. The main purpose is to measure how well the model generalizes to new data, indicating its ability to make accurate predictions in real-world scenarios. It's vital to ensure the test data is independent from the training data to avoid overfitting and achieve a fair evaluation. Various performance metrics like accuracy, precision, and recall are used to assess the model's performance on the test dataset. In smaller datasets, cross-validation techniques split the data into folds for training and testing on different subsets to provide a more robust evaluation. The test dataset can reveal overfitting if the model performs well on training data but poorly on the test data. It also plays a role in assessing bias and fairness, ensuring the model's predictions are equitable across different groups. Test datasets can be used for hyperparameter tuning to improve the model's performance, but caution is needed to avoid overfitting to the test set. The test data should ideally represent the data the model will encounter in real-world deployment. The evaluation results from the test dataset inform decisions about deploying or further refining the model. Overall, Chapter 2 emphasizes the importance of using a separate test dataset for unbiased evaluation of a machine learning model's generalization ability and real-world performance. Synopsis of Chapter 3, Unseen Dataset. This chapter focuses on a key element in evaluating machine learning models, the unseen dataset. Key takeaways. An unseen dataset, distinct from both training and test datasets, provides a final test of a model's performance on completely new data. Its main purpose is to assess the model's real-world generalizability, ensuring it can make accurate predictions beyond the data it was trained on. To avoid bias and achieve a fair evaluation, the unseen dataset should be completely independent from any data used for training or testing. Evaluating the model on this dataset reveals its ability to cope with novel data and real-world challenges, essentially simulating its performance in deployment. Results from the unseen dataset help determine if the model is ready for deployment or needs further refinement. Unseen data can also be collected later for ongoing monitoring and updates, enabling continual learning for the model in dynamic environments. Similar to the test dataset, various evaluation metrics based on the task, classification, regression, etc., are used to assess the model's performance on the unseen data. Overall, Chapter 3 highlights the crucial role of an unseen dataset in validating a machine learning model's robustness and reliability for real-world applications. Synopsis of Chapter 4, Machine Learning, ML. This chapter delves into the core of AI, machine learning. Key takeaways. Machine learning is a subfield of AI where algorithms learn and make predictions based on data, replacing explicit programming. Different types of ML exist, each suited for specific tasks. Supervised learning uses labeled data for tasks like classification and regression. Unsupervised learning searches for patterns within unlabeled data for tasks like clustering and dimensionality reduction. Reinforcement learning involves agents making decisions in an environment to maximize rewards, used in game playing and control systems. Other types include semi-supervised, self-supervised, and transfer learning. Key concepts in ML include features, input variables, labels, desired outcomes, models, mathematical representations, training, optimizing parameters, testing, evaluating performance, and avoiding overfitting, memorizing, or underfitting, not capturing patterns. Hyperparameters control the learning process and can be adjusted for optimal performance. Machine learning has vast applications in fields like image/speech recognition, natural language processing, recommendations, predictions, autonomous systems, healthcare, fraud detection, finance, and robotics. Challenges include data quality/quantity, choosing the right model and tuning its parameters, ensuring ethical and fair practices, making the model interpretable and transparent, and handling deployment and scalability. Machine learning is a rapidly evolving field with immense potential to solve complex problems and shape the future of technology and automation. Overall, Chapter 4 provides a comprehensive overview of machine learning, its various types, applications, and challenges, highlighting its significance in the evolving technological landscape. Synopsis of Chapter 5, about deep learning. Main ideas. Deep learning is a powerful subfield of machine learning within artificial intelligence. It uses deep neural networks, with many layers, to automatically learn patterns and representations from data. Key components of deep learning. Artificial neural networks, ANNs inspired by the brain, interconnected nodes process information with weights and activation functions. Deep neural networks, DNNs multiple hidden layers allow learning complex, abstract features. Training, adjusting weights and biases to minimize prediction error, supervised learning. Activation functions, introduce nonlinearity for approximating complex functions. Applications. Computer vision, image classification, object detection, image generation. Natural language processing, NLP language translation, sentiment analysis, text generation. Speech recognition, voice assistance, transcription services, speaker recognition. Healthcare, medical image analysis, disease diagnosis, drug discovery. Autonomous vehicles, object detection, path planning, control systems. Recommendation systems, personalized content and product recommendations. Challenges and considerations. Large amounts of data needed for training. Computationally intensive training requiring specialized hardware. Overfitting and interpretability concerns. Advancements. New architectures like CNNs and transformer models. Transfer learning and pre-trained models for knowledge transfer. Overall, the chapter highlights the power and potential of deep learning, while acknowledging its challenges and ongoing advancements. Synopsis of Chapter 6, Deep Neural Networks. Main ideas. Deep neural networks, DNNs, are a type of N with many layers, making them powerful for handling complex data. They are characterized by deep architecture, multiple hidden layers for learning hierarchical features. Automatic feature extraction, can discover useful features directly from raw data. Layered structure, input, hidden, and output layers for data processing and prediction. Training and backpropagation, adjusting weights and biases to minimize error in supervised learning. Activation functions, introduce nonlinearity for complex function approximation. Applications across various domains. O. Computer vision, NLP, speech recognition, healthcare, autonomous vehicles, recommendation systems. Challenges and considerations. O. Data requirements, computational demands, overfitting, interpretability issues. Advancements. O. New architectures like CNNs and transformers. O. Transfer learning and pre-trained models for knowledge transfer. Overall, the chapter emphasizes the power and impact of DNNs in various fields, while acknowledging their challenges and ongoing advancements. Synopsis of Chapter 7, Python Libraries. Main ideas. Python is a popular language for AI and machine learning due to its rich library ecosystem. Common libraries for AI development include O. Data science and machine learning, NumPy, Pandas, Matplotlib, Scikit-learn, TensorFlow, and PyTorch. O. Web development, Django, Flask, FastAPI, and Requests. O. Data visualization, Seaborn and Plotly. O. Natural language processing, NLTK and Spacy. O. Game development, Pygamy and Cocos 2D. O. Scientific computing, SciPy and SymPy. O. Database access, SQL Alchemy and PyMySQL. O. Image processing, Pillow and OpenCV. O. Automation and scripting, Beautiful Soup and Selenium. These libraries offer functionalities for diverse tasks, making Python versatile and powerful. Overall, the chapter highlights the vastness and importance of Python libraries for different AI and non-AI applications. Synopsis of Chapter 8, Output Layer. Main ideas. The output layer is the final part of a neural network that generates the model's predictions. Its structure and function depend on the specific task. O. Regression, one neuron for continuous value output. O. Binary classification, one neuron with sigmoid activation for probability prediction. O. Multi-class classification, multiple neurons and softmax activation for class probabilities. Activation functions determine the format of the predictions. O. Linear for regression. O. Sigmoid for binary classification. O. Softmax for multi-class classification. Loss functions and evaluation metrics also depend on the task. Decision thresholds in binary classification convert probabilities to final predictions. Overall, the chapter emphasizes the crucial role of the output layer in determining the outcome of a neural network for different tasks. Synopsis of Chapter 9, Summary. Key points. Typical AI project workflow. O. Collect and pre-process data. O. Split data into training and testing sets. O. Train the model on the training data. O. Tune model parameters. O. Evaluate model performance on the test data. O. Deploy the model for real-world predictions. Libraries used. O. Deep learning, TensorFlow, PyTorch. O. Machine learning, Scikit-learn. Output layer design, adapts to specific tasks, classification, regression, etc. This summary captures the essential steps involved in an AI project, showcasing the importance of data, model training, evaluation, and deployment. Additionally, it highlights the role of specialized libraries for tackling different aspects of the process. Synopsis of Chapter 10, AI Conclusion. Main ideas. AI, encompassing subfields like machine learning, deep learning, NLP, computer vision, and robotics, has achieved significant progress in various applications across industries. Positive impacts. O. Potential to revolutionize daily life and work through improved automation, problem solving, and decision making. Challenges and concerns. O. Potential job displacement due to automation. O. Data privacy and security issues. O. Responsible development and deployment of AI systems. Balancing benefits and risks. O. Striking a balance is crucial to maximize AI benefits while minimizing risks. Responsible approach. O. Applying AI thoughtfully and responsibly for societal improvement. Overall, the chapter highlights the significant advancements of AI while acknowledging its challenges and emphasizing the need for a responsible approach to harness its potential for good. Synopsis of Chapter 11, How to Design an AI Management Dashboard. Main ideas. Purpose, create a user interface for visualizing and leveraging AI-generated data for decision-making and monitoring. Steps. 1. Define objectives. What AI insights are needed and how will they be used? 2. Identify key AI metrics, predictions, recommendations, or data relevant to the objectives. 3. Integrate data. Ensure access to necessary AI data from models, APIs, or data sources. 4. Select dashboard tools. Choose platforms like Tableau, Power BI, or custom development tools. 5. Wireframe the layout. Rough sketch of the dashboard with data and insights placement. 6. Visual design. Apply consistent layout, colors, fonts, and icons for usability. 7. Visualizations and widgets. Use charts, graphs, tables, and custom elements to effectively represent AI results. 8. Interactivity. Allow users to explore data with filters, drill down options, and tooltips. 9. Real-time updates. Display AI model updates as they happen. 10. Mobile responsiveness. Ensure functionality on various devices. 11. User testing and feedback. Gather feedback for iterative design improvement. 12. Data security and compliance. Protect data and comply with regulations. 13. Documentation and training. Provide clear explanations and user support. 14. Feedback mechanism. Allow users to report issues and suggest improvements. 15. Integration. Connect the dashboard with AI models, data storage, and other tools. 16. Regular maintenance and updates. Keep the dashboard updated with new insights and user needs. 17. AI model health monitoring. Track model accuracy, latency, and reliability. 18. Ethical considerations. Present AI insights fairly, unbiasedly, and interpretably. 19. Iterate and improve. Continuously refine the design based on feedback and changing requirements. Outcome: a user-friendly, informative dashboard that empowers stakeholders with AI-driven insights for decision-making. Overall, this chapter provides a comprehensive guide for designing and implementing effective AI management dashboards, considering various aspects like data integration, visualization, user experience, ethical considerations, and continuous improvement. Synopsis of Chapter 11, How to Design an AI Management Dashboard. Main ideas. Purpose: create a user interface for visualizing and leveraging AI-generated data for decision-making and monitoring. Steps. 1. Define objectives. What AI insights are needed and how will they be used? 2. Identify key AI metrics, predictions, recommendations, or data relevant to the objectives. 3. Integrate data. Ensure access to necessary AI data from models, APIs, or data sources. 4. Select dashboard tools. Choose platforms like Tableau, Power BI, or custom development tools. 5. Wireframe the layout. Rough sketch of the dashboard with data and insights placement. 6. Visual design. Apply consistent layout, colors, fonts, and icons for usability. 7. Visualizations and widgets. Use charts, graphs, tables, and custom elements to effectively represent AI results. 8. Interactivity. Allow users to explore data with filters, drill down options, and tooltips. 9. Real-time updates. Display AI model updates as they happen. 10. Mobile responsiveness. Ensure functionality on various devices. 11. User testing and feedback. Gather feedback for iterative design improvement. 12. Data security and compliance. Protect data and comply with regulations. 13. Documentation and training. Provide clear explanations and user support. 14. Feedback mechanism. Allow users to report issues and suggest improvements. 15. Integration. Connect the dashboard with AI models, data storage, and other tools. 16. Regular maintenance and updates. Keep the dashboard updated with new insights and user needs. 17. AI model health monitoring. Track model accuracy, latency, and reliability. 18. Ethical considerations. Present AI insights fairly, unbiasedly, and interpretably. 19. Iterate and improve. Continuously refine the design based on feedback and changing requirements. Outcome: a user-friendly, informative dashboard that empowers stakeholders with AI-driven insights for decision-making. Overall, this chapter provides a comprehensive guide for designing and implementing effective AI management dashboards, considering various aspects like data integration, visualization, user experience, ethical considerations, and continuous improvement. Synopsis of Chapter 12, Applications of AI across industries. Main ideas. AI has wide-ranging applications across various industries and domains. Key areas include healthcare, diagnosis, drug discovery, personalized medicine. Finance, algorithmic trading, risk assessment, customer service. Autonomous vehicles, navigation, object detection, decision-making. Manufacturing, predictive maintenance, quality control, supply chain optimization. Retail, recommendation systems, inventory management. Natural language processing, chatbots, virtual assistants, language translation, sentiment analysis. Education, personalized learning, automated grading, language learning. Cybersecurity, threat detection and response, anomaly identification. Entertainment, content recommendation, AI-generated art and music. Agriculture, crop management, soil analysis, precision agriculture. Energy, grid management, power distribution optimization, equipment failure prediction. Environmental monitoring, climate change analysis, deforestation, and pollution monitoring. Space exploration, data analysis and decision-making for autonomous probes, rovers, and telescopes. Legal, document review, legal research, outcome prediction. Human resources, candidate screening, performance assessment, HR task automation. Government and public services, predictive policing, census data analysis, traffic management optimization. AI applications are constantly evolving and expanding, impacting many aspects of our lives and industries. Overall, this chapter showcases the diverse and transformative potential of AI across various sectors, highlighting its growing impact on daily life and future advancements. Synopsis of Chapter 13, Building and Integrating an AI Engine. Main ideas. 3-phase AI engine building process. Phase 1, train the AI on labeled data using machine learning and deep learning techniques. Phase 2, validation test the AI on unseen data to refine its performance. Phase 3, deployment monitor and adapt the AI as it interacts with real-world data. Audit of the AI engine, ensure data bias, explainability, robustness, and performance monitoring. Benefits of integrating AI with an ERP system. Improved decision-making through data analysis and pattern recognition. Automated tasks and increased efficiency. Enhanced forecasting and predictive maintenance. Fraud detection and protection. Integration approaches, direct API, data warehouse, pre-built connectors. Challenges and considerations, data quality, security, and privacy, user adoption, model explainability. Examples of AI integration in ERP, chatbots, inventory optimization, financial risk analysis, production planning. Overall, this chapter outlines a comprehensive approach to building and integrating an AI engine with an ERP system, highlighting the potential benefits, challenges, and practical considerations for organizations considering this path. Synopsis of Chapter 14 delves into the realm of generative artificial intelligence, AI, showcasing its capacity to produce novel content rather than merely analyzing existing data. This subset of AI, rooted in deep learning and neural networks, encompasses diverse applications across various domains. Text generation, generative AI crafts human-like text, generating news articles, poetry, code, etc. Notably, models like GPT-3 exemplify this capability. Image generation, AI creates images, artwork, or photos that don't exist in reality. Generative adversarial networks, GANs, excel in generating realistic visuals. Voice and audio generation, AI systems fabricate authentic speech or music, utilized in voice assistants, example Suri, Google Assistant, for human-like responses. Video generation, generative AI crafts video content, such as deepfake videos or animated sequences. Data augmentation, in data science and machine learning, generative AI fabricates additional training data to enhance model performance. Content recommendation. Certain recommendation systems leverage generative AI to suggest products, movies, or music based on user preferences. Simulation and game development. In gaming, generative AI creates game content like levels, characters, and dialogues. Drug discovery and molecular design. AI models generate novel drug compounds or molecular structures for drug discovery and materials science. While generative AI bears immense creative potential across industries, ethical concerns arise, especially concerning deepfakes, misinformation, and intellectual property rights. Responsible and conscientious use of this technology is crucial to harness its potential while navigating these ethical challenges. I hope this synopsis will help you. Thank you.